name is Richard Cuerden. I'm a director at TRL, the UK's Transport Research Laboratory, and I'd like to talk for the next 10 minutes on the theme of the post-crash response, specifically on eCall, in-vehicle emergency call service. We're all very familiar with the 5 pillars and part of the decade of action. When I talk about eCall, what I think is quite interesting is that it very much fits in the post-crash response. It's very much around how do we get the best care to people who've been involved in collisions as quickly as possible. But to do that, it involves changes to our vehicles and also to our road safety management system. The 5 pillars are very interesting, and they're often then taken and put into a safe system approach. The picture on the screen at the moment is the Australian schematic, but it's a common picture we see with concentric circles showing safe roads, safe speeds and so on. However, what is often missing from these pictures is the 1st and 5th pillars, and I think this is a real shame. A safe system must have leadership, it must have roles and responsibility and targets. Otherwise it's uncoordinated, it's disjointed, it doesn't work, and that needs to be shown, it needs to be represented on these pictures some way. Equally, the 5th pillar, the post-crash response, really needs to be thought through a little bit more and not taken for granted. We can really improve how we get care to people in all countries, and we can certainly consider how we can improve the medical care that people receive. And indeed the care people receive who've suffered bereavements. Now, you're all very familiar with the WHO text on the post-crash response, so I won't dwell on this too long. There are 7 activities that are documented very well and that cover a whole range of things. Presentation, I've taken, of those activities, I've identified 1, 5 and 7, where there are wording that really fits well with the eCall system, and indeed as we go to a more modern vehicle fleet, in-vehicle data. Increasingly our vehicles are storing data around what they're doing all the time, and certainly capturing data in the event of a collision. So what is eCall? Okay, well, eCall has been approved within the European Union, and what that means is that if a car is involved in a collision, the car has been designed with standard protocols. That means it can send a signal that's going to be in a format, the data is going to be readable by the control room. So that's sent via a cellular network, a 2G or 3G connection in the form of a text message. That is received at the control room. The control room can then attempt to try and speak to the driver or the passengers within the vehicle. If they can speak to them, that's great. They can find out more information around the incident. If they can't, they can just make the decision to send the response, because maybe the people in that vehicle are unable to talk because of their injuries. So what eCall does is it makes that call immediately when perhaps people previously wouldn't have been able to make the call, or there would have been a lag because you would have waited for somebody to be able to get themselves into the right place, or another witness to come along and make the call. So it speeds up the notification and the response times. eCall doesn't just work in the event that your vehicle is being involved in a collision. It also means that if you or I are driving on a particular route and we were to come across a collision, there's a button within our vehicles or a system that allows us to notify very quickly that we've witnessed a collision or we've seen the aftermath of a collision. And what that means is that we can pinpoint the location of that collision straight away to the emergency services and then speak to them around what we've seen. Again, getting better notification for road collisions. When this first came about, there was concerns that the control rooms would be overrun with notifications of collisions on our roads. We've thought about this hard, and eCall is designed for severe collisions. It's very unlikely that we're going to see a significant rise in calls due to people pressing an eCall button rather than dialing 112 or 999. The other concern people had was a big brother. People felt that if an eCall system was on their vehicle, it would be tracking their car as they went around their everyday business. That simply is not true. eCall is not operable. It doesn't track the vehicle at all unless there's been a collision or unless you press the emergency button. Now, the research and development that's gone into eCall has been incredibly complicated, and I don't really have time to go into it here, other than to say that there's been some really key points where standardization has come into play, and some big projects, for example the HERO project, that really began to prove and demonstrate that this technology would work. The part of my talk I'd just like to spend a little bit of time on is perhaps something that is less familiar to most people anyway, which is how do we make a vehicle, how do we design a vehicle, how do we give the functional requirements to a vehicle manufacturer so they can make that vehicle that in the event of a collision it will always be able to make that eCall. It will be designed for collisions and designed to make the response call. And that's something that TRL have been helping the Commission do. The work TRL has done has been over two phases. The first really considered the technical considerations. It was an information gathering piece of work with industry and regulators, and it theoretically set out what an eCall type approval system ought to look like. Phase, the second report, said, okay, if you've got those areas, what are the technical requirements? What should the vehicle be designed to do in the event of a collision? And this is when life can get a little bit technical, so excuse me, but there are 6 tasks, and essentially all of these tasks are concerned with making sure that a car, and it is a car in this regulation, a car will be able to withstand, or specifically the components of the eCall system will be able to withstand the collision that it's experienced and still be able to make that eCall. It will still be able to work. I'm going to talk about 2 of these particular tasks. And if I take the first one, these tasks work hand in hand. The first one is basically how do we test the components of the eCall system to really make sure they'll work at quite severe crash speeds and still talk to one another and make that eCall. And the second is how do you demonstrate that through full-scale crash test assessments. The pictures you can see on your screen, the top one shows a board that's mounted to the impact sled rig that's in the bottom picture. So if you mount the eCall components, so the accelerometers, the microphone, the speaker, the processor unit, the antennae and so on, if you mount those components to a board, you can put them in different orientations, different angles. You can then accelerate the sled or decelerate the sled actually, on this particular example as it hits the wall. So those components experience severe impact conditions. You can then test those components still work. This slide really just repeats what I just said. What it also says is that by being able to test the components in the way that we've described here on a sled test, it means you don't have to do new big full-scale crash tests. You don't have to buy new cars and crash them in rollovers and extra side impacts and so on. You can simply take these components, put them on a sled test and run through the tests. What it means is that if you're a vehicle manufacturer and you want to change any of the components of your eCall system, you can simply rerun a relatively cost-effective sled test rather than having to test the whole vehicle. What was really important to me when we were thinking about the sled test though was to make sure that the deceleration pulse, the severity that we tested those components to, was replicable of collisions where we knew people were surviving but perhaps sustaining quite serious injuries, life-threatening injuries, where we know we needed to get the emergency services to them. So please excuse the rather technical slide, but what it's trying to show is that if you take data from the most severe or some of the most severe impact tests where we've got the deceleration pulse and you put that into, you smooth those curves, we expect the components always to be able to withstand relatively high levels of deceleration. In this test it's up to 77 G, or 77 times the force of gravity. Very quickly on the full-scale test assessments, because I have a habit of talking too long. There are already 2 full-scale tests. So what we were interested in doing was introducing new tests to the burden of manufacturers. We didn't feel that was actually necessary. So what we expect manufacturers to do is to meet the front and side impact tests that they're required to do in Europe already, but after they've done that, they must demonstrate that their system generates an eCall. And that's it. That's the regulatory summary, if you will, of how manufacturers from April, the 31st of March, April this year, will design their vehicles, and all new car models sold in Europe will be fitted with eCall systems that will work in the vast majority of the most severe collisions on our roads. I wanted just to have a quick think of post-2020. So what eCall is doing is it's introducing connected vehicles, in this case connected with the infrastructure, talking to control rooms. But soon we may have vehicle-to-vehicle connections. So, for example, an emergency vehicle could be approaching from behind and could warn us, and we could be able to get out of its way. A vehicle ahead of us could have experienced some dangerous road conditions and could warn us around potential hazards. Future versions of eCall may be quite intelligent. Those versions may not just say you've had a collision, it may be able to make some judgment of how severe that collision was and how ill you are, or the people in the vehicle, and pre-warn the trauma teams appropriately. I mentioned earlier in vehicle data, future European regulation may require event data recorders to be mandated within vehicles. That really introduces a whole new source of evidence that will really help us to understand more about collisions, which is great because that's going to improve the collision investigation standards, but it's also going to allow us to learn a lot more about how we prevent future collisions. And very, very quickly, we have to evaluate the effectiveness of eCall. Is it working? From April this year, when we're seeing it in place, are all the systems actually working? Because if they are, it may be cost effective to roll it out into other world regions. And finally, eCall, of course, could work for other road users. There are systems on the market now for motorcyclists and pedal cycle helmets with sensors fitted to the helmet that talk to the mobile phone. Very simple. eCall is a cost-effective solution. It's working now within Europe, but it's a system approach. It sits within the post-crash response, but you've actually got to upgrade your road safety management or your management of the roads and your emergency response, your 112 or your 999 call systems. You have to change vehicle type approval because the vehicles have to be standard, they have to use standard communication techniques, and you want them to be equally reliable at making those calls. And last but I guess not least, we shouldn't take for granted that mobile network operators must deliver eCalls, and they must do that for free. Thank you very much for listening to me, and I'm sorry I wasn't able to join you in person. If there are any questions, I'd be very happy to answer them, and perhaps if we collect them on through email, I can respond as quickly as possible. Thank you very much for your attention.